Hey guys, welcome to question 2 for the 2019 level 2 probability paper. So a company produces handmade plates. The weights of the plates can be modeled by a normal distribution with a mean of 450 grams and a standard deviation of 35 grams. Okay, so find the probability that a randomly selected plate weighs between 450 grams and 520 grams. Alright, so for this question we want to find the probability that a randomly selected plate would say x, so x is between 415 and 520. So we want to find the probability that x is between these two numbers. So how we're going to do this, so we're going to have a standard deviation of 35 grams and a mean of 450 grams. So our mean is equal to 450 grams and our standard deviation is equal to 35 grams. We're going to go on to, in our graphics calculator, we're going to go menu. Sorry, we're going to go menu. And then we're going to go all the way down to stats. And then we're going to be clicked on distribution. And we're going to go onto the normal distribution. So we're going to go norm. And then we're going to go NCD. And if you click on NCD, you want to make sure that's set to variable. And now we can plug in our numbers. So we have our standard deviation, we will plug in as 35 grams, the mean will be plugged in as 450 grams, and we want our lower value to be 415 grams and our higher value to be 520 grams. So our lower is 415 grams and our upper would be 520 grams. And that's all you have to do. So you say our lower is 415 and upper is 520. And our standard deviation, and yeah, so that should get you an answer of 0.8186, and this should be an achieved question here. We want to find the probability that a randomly selected plate is less than 400 grams. We want to find the probability that x will be less than 400. So in this case, we'll use the exact same. We'll go to NCD, and we will use our same mean and standard deviation, but this time we want to find something that's less than 400 grams. So the maximum would be 400. So our upper value this time would be 400, and our lower value would be a very small number. So a very small number, I usually just use -1 times 10 to the power of 99. So our upper value is 400. Lower value would be -1 times 10 to the power of 99. And that actually gives you an answer of, sorry, this is a bit squished up here. So probability of x is less than 400. That equals to 0.0766. And that should be another achieved mark here. Alright, B. The company rejects the heaviest 10% and the lightest 15% of all plates made. What is the range of weights that the company accepts? So for the easiest way to do this question is to draw a rough diagram of your normal distribution. So we can just draw a rough diagram, for example, something like this. So you know the company rejects the heaviest 10%. So let's just say this is the heaviest 10% here. So this is rejected. So I say this is 10% and this is rejected. And also the lightest 15%. So we say, for example, this part will be 15%. And this is also rejected. And this middle part here, this is the accepted values. So basically what we're trying to find here is trying to find this, for example, let's just say this is our A value here and our B value here. So we're trying to find these two values here, and our range would be between A to B. So our range would be A to B. And that would be our accepted range. So how we approach this question, we will use our standard deviation. It's told to be 35 grams, and our mean is 450 grams. However, this time we have the probability. So for example, we have the heaviest 10%. We're trying to find the weight. So basically, we're going to be doing the opposite thing we were just doing in questions A, I, and I. So this time we're going to use distribution. You're going to go to normal distribution, but this time you're going to be going to the inverse section. So basically you're going to go normal distributions, and so you go distribution, you're going to go to normal, I'm going to go normal, and then we're going to go inverse. So that's displayed as INVN, and that will take you to an inverse page. So once again, you want to set it to variable. All right, so this time, let's say we're trying to find our, let's try to find our B value first. Our B value first is the heaviest 10% of plates. So once again, we're going to use our standard deviation as 35 and our mean as 450. Okay, so you see that it will ask you for tail. So tail means what side it is. So for B, we're looking at the heaviest 10%, which means the greatest 10%. So as you can see, this is on the right direction of the normal distribution. So our tail should be set to right. So we know that the 10% of heaviest plates will be rejected. So the area, so 10% can be rewritten as a decimal as 0.1. So our area will be 0.1, and you'll press enter on your calculator. And you should get that B equals to 494.85 grams. In terms of our A value, this time we're looking at the left part of the graph. So you're going to set your tail to left. So to set your tail to left, you can just use F1 and F2 to alternate between the two. And with tail left, and then your area would be 15%, which is 0.15. So that actually gives you an A value of 413.72 grams. So our range, so this will be our A here will be 413.72, and our B here will be 494.85. So between these two is our accepted range. So we're going to state that our range of accepted would be 413.72 to 494.85. So just grams and grams. And that would be your final answer for this question. And this should be available for a merit level question. In terms of getting an achieved, I'm thinking if you find either the A value or the B value, so either one of these should get you an achieved. So this is achieved, okay. All right. Taylor makes the plates at the company. Her plates also have a mean weight of 450 grams. However, the standard deviation of the weights of the plates of Taylor is higher than the standard deviation of the weights of the company overall. So we know that the Taylor will make standard deviation is greater than 35 grams, which is the company overall. So what can be deduced from this about the way that Taylor makes her plates compared to the company overall? So in terms of standard deviation, what we know about it is that we know that 99 is debatable, so it's about 99% to 99.5% of the total data will lie between 3 standard deviations of the mean to both left and right. So if I drew a diagram like this, so let's just say this in the middle here, that would be our mean. So 99.5% of the data will lie within 3 standard deviations. So let's say this is 1 standard deviation. Let's say this is 2 standard deviations, and let's say this is, for example, 3 standard deviations. So this one here will be very small, will be just be 0.05, maybe even smaller than that. So basically, most of the data will be lying between 3 standard deviations to both the left and the right. So we say 1 standard deviation here, maybe 2 here, and 3 here. So basically, what we know about a high standard deviation, which means that each standard deviation is going to have a bigger distance because each standard deviation is greater. So each standard deviation will be a greater distance from the mean. Hence, our total graph will actually have a higher spread. So Taylor will be making her plates with a bigger range. So she might make, for example, she might make more lighter plates and then more heavier plates in the company because she has a higher spread. So basically, a very different range. So we're going to say that in our answer here. So we're going to say, for example, we could say, because 99 to 99.5% of the data lies between 3 standard deviations of the mean. By having a high standard deviation, we're going to use SD, just so standard deviation is SD. So just abbreviation. So by having a higher standard deviation, Taylor's plate, Taylor's normal distribution will be have a higher range. So Taylor will have a higher range than the company. For example, she might make more lighter and heavier plates. So basically, you can just say a high spread of data. Alright, so this should be, thinking this should be either an achieved, I think it should be a merit level question here. And to get an achieved, you can maybe just make a statement that it will have a higher range, so a higher range in the company. Maybe up to here actually. So maybe just this part might get you an achieved. So for Taylor's plates, more than 75% weigh more than 400 grams. What is the range of possible values for the standard deviation of the weights of Taylor's plates? So we know that the standard deviation we don't know. However, we know that the mean remains the same, which is 450 grams. Mean weight remains the same here. So for this question, we actually have to convert into a normal what do you call it again? A standard normal, and that means that is our very basic graph with our mean as 1 and our mean as 0 and standard deviation is 1. The reason we want to do this is because we want to find our z value. So for example, remember how in the last question we were finding out this a and b values. So instead we're going to be using a standard normal graph and we're going to be finding the z value. So this a and b will be corresponding to the z values for our standard normal. The reason we want to do this is because we want to be able to use the formula that z equals to x minus the mean over the standard deviation. Because the reason we cannot use we used a strategy for this. We directly used the graph in the question. However, the reason we have to convert to a standard normal for this question is because we're not given the standard deviation. We have to find the standard deviation, which means that we cannot use our inverse. So remember, our inverse requires us to enter a standard deviation. However, we actually do not have a standard deviation, which means we have to use this formula. So our z equals to x minus our mean over our standard deviation. The reason we want to use this formula is because this formula requires for there to be a mean of 0 and a standard deviation of 1. So this is a standard normal. And once we have our z value, we can plug in. So our x value will be corresponding to this weight here, 400 grams. Our mean we know is 450 grams. And therefore, we can use this to find our range of our standard deviations. So we're going to convert to our standard normal. So it's exact same shape, normal distribution. In this case, our mean would be 0 and our standard deviation would be 1. Okay, so we're going to use the same logic. So 75% weigh more than 400 grams. So if I drew a line here, that means this whole area must be greater, this whole area must represent 75% of the data. And this here will actually be our z value that we're trying to find out. So we're trying to find out for what value of z will 75% of data be to the right of z. So what value of z will have 75% of the data to the right of z. Right, so in this case, we're going to be using our... Okay, so once again, we're going to be using our inverse, okay, but this time we're going to be using our standard normal with these values. So our mean is 0 and our standard deviation is 1. So our inverse, so our standard deviation is 1, our mean is 0. And our tail is right because we're looking at the right-hand side of the graph. So our tail is actually set to right and our area is 0.75. So it should come out that your z, first you can just write, for example, tail right, area 0.75. So you should come out that your z value is equal to negative 0.6745. It's good to do it to 4 decimal places so you can get a more accurate answer. So now that you have your z value, we can use this z value into this formula we were talking about earlier in order to find our standard deviation. However, it asks us for a range of possible standard deviations. So notice that, for example, let's just say this is our mean. This is our mean of 0. As we go to the left of the mean, it's going to become less and less. And if we go to the right of the mean, it will become more and more. So it says at least 75% way more than 400, which means that z could be anywhere from here. So it could be here, z could be here, as long as more than 75% of the plates weigh more than 400 grams. And like I was saying before, if you're moving to the left of the mean, then the z value will be decreasing gradually. So this z value here will actually be less than this z value here. So this z value here will be less than this z value here. However, there will be more area to the right of the graph. So how is that relevant? That's relevant because in terms of this formula, our z value has to be at least this number. So it can be anywhere less than this number and it will still fulfill the requirements. So actually in this question, we'll actually be using z will be less than everything that is so x minus mean over standard deviation. So that will be the formula we'll use to find the range. So okay, now we can plug in our numbers. We say negative 0.6745 is less than our x value, which is 400 minus our mean, which is 450, over our unknown standard deviation. If we move the standard deviation to the other side, so now it's basically just algebra now, okay? So we can just use a little bit of algebra here. So this will equal to 400 minus 450 is negative 50. So negative 50 divided by negative 0.6745, and that gives us, oh sorry, it's not equal to, it's less than. So that gives us the standard deviation must be less than 74.13. Alright, so you might be thinking, oh, we're done now. However, it is important to link it back to the question because remember in this question up here, they were saying that the Taylor will have a higher standard deviation than the company overall. If we go back to the previous question, we'll see that the company overall has a standard deviation of 35 grams. So the question does tell us that Taylor has a standard deviation more than 35. So that's also something we know. So we also know that standard deviation must be greater than 35. So therefore, our range of standard deviation must be between 35 and 74.13. So we can write that on notation as this. Oh, sorry. So 74.13, so grams and grams. And that will be your final answer here. So in terms of getting an excellence, if you can work all the way to this final line here, you'll get an excellence. In terms of getting a merit grade, if you can just work up to here, that will get you a merit. And to get an achieved would be perhaps finding the z value here. So finding the z value here, that should get you an achieved mark. Yeah, so I agree. It is a bit of a hassle putting this 35 is putting that standard deviation is greater than 35. It is a bit of a hassle and it is very easy to miss, but yeah, it's a bit nasty, but unfortunately that's how maths is sometimes. And that's how NCA is sometimes, so can't do anything about it, unfortunately. Because a lot of people missed this. So some people just left their final answer as standard deviation is less than 74.13. A lot of people told me they did that, and it's really a shame, really, because this whole question is basically the hardest part of the question is maybe being able to find up to this step, and this last step here. So this last step here is actually just really just seeing how accurately you can read the question, which is it's a bit cheeky, but yeah, what can you do about it, unfortunately. Alright, so we'll move on. So Eddie also makes plates at the company. 2 of his plates were randomly selected and they both weighed over 520 grams. Assuming that the weights of Eddie's plates have the same normal distribution as the weights of the plates for the company overall, what is the probability that 2 randomly selected plates made by Eddie would both weigh over 520 grams? So we want the probability that 2 randomly picked plates would be greater than 520. So we'll just say 2 in a row, for example. Alright, so once again, we're going to be going to our NCD. So we know that this is the same normal distribution as the company overall. So our mean was our standard deviation is 35, and our mean is 450 grams. So once again, we're going to be using our NCD to find the probability that any plate is greater than 520 grams. So stat, distribution, normal distribution, and NCD. So our lower value for this, would be, we want to find the plates, greater than 520. So our lower value this time will be 520. So the minimum is 520. And we're looking at any graph that is greater than that. So our upper value would be an extremely big number. So lower would be 520 grams. And our upper would be a very large number. So for example, 1 times 10 to the power of 99. And our standard deviation is 35 and mean 450. Alright, so our probability comes out to be, our probability equals to 0.02275. However, it says that probability of 2 randomly selected plates made by Eddie. So that means we have to square this in order to find our answer. So if we square this, 0.02275 squared, that is a very tiny number. That is actually probability of this is equal to p squared, which equals to 5.18 times 10 to the power of negative 4. So this negative 4 represents just moved the decimal point 4 times to the left. So that's actually a very, very small probability here. And that actually links to the next question, which I strongly detest. However, what can you do about it? So what could your answer about DI suggest about the actual distribution of the weight of Eddie's plates compared with the overall distribution for the company? You must support your answer by using relevant probability calculations or diagrams. So the reason I didn't really like this question is because they weren't really specifically clear about what relevant probability calculations you needed to include, because it seemed like you could do anything, like really, like it doesn't really specify like what type of probability calculations they were looking for. And it is a bit confusing the way they worded it. So in part D, they said that Eddie's plates have the same normal distribution. And then in II, they suggest that the Eddie's plates is different from the normal distribution, which is a bit confusing. But yeah, we have to work with it. So basically, the most likely part is that the standard deviation and the mean of Eddie's plates will be different. So the mean will probably be very much higher for Eddie's plates in order for them to be more likely to pick up a plate that is greater than 520 grams. Because right now the probability is extremely low. So the more likely suggestion is that Eddie's normal distribution has a much higher mean. Or maybe Eddie's plates has a much higher standard deviation. So its higher standard deviation means he has a much higher spread of data. If he has a much higher spread of data, he actually has a higher chance to pick up a higher weighted plate. So one of those possibilities. So for example, you could say that the mean is higher, or standard deviation is higher. I'm just going to use SD, sorry. Okay, so basically how we're going to use probability calculations, that is a really hard question. So for the mean, I could think the only thing I could think of is what would the mean have to be in order for Eddie to have a 50% chance of picking a weight that is greater than 520. So once again, we don't know the new mean, so we have to use our standard normal. So for example, we're going to use our standard normal again. That's a very messy graph, but forgive me. So you want to find the probability that Eddie has a 50% chance of picking a plate greater than 520 grams. So we'll say this is our z value. Our mean is 0 and our standard deviation is 1. So once again, we're going to use our calculator. We're going to go NCD. So not NCD, inverse. So our tail, it doesn't really matter which way the tail is. So 50% on the right, 50% on the left. So you can use either right or left. 0.5, mean is 0, and standard deviation is 1. Okay. So our, our z value is actually equal to 0. So we're going to use our z equals to x minus our mean over our standard deviation. So let's say our standard deviation stays the same. So we'll say that z equals to x, which is 520, minus our mean, which you don't know, divided by, sorry, that's 0, divided by our standard deviation. So therefore 0 standard deviations is equal to 520 minus u. So therefore our u value would have to be 520 grams. So as you can see, in order for Eddie to have a 50% chance of getting a plate that is 550 grams or greater, would be 500. The mean would have to be 520 grams. So the mean in the company is 450 grams. So this is the company, and Eddie's plates would be 520 grams, just for a 50% chance of picking a plate that's greater than 520. So you could say for a 50, what am I doing? Sorry. For a 50% chance of a plate higher than 520 grams, the mean would be 520 grams. And you can use the exact same strategy to find out the standard deviation as well. So this time we'll keep the mean at, we'll say the mean is still equal to, standard deviation, mean. Yeah, okay, so we did that then. Right, so this would be okay. So probably it's not the best idea to use 50%. We'll say 75% actually, because 50% actually will give us an invalid answer for the standard deviation. I just realized. For example, if we use 75%, so let's just say maybe here, so that's our z value, and that's 75. So this time we would have our z value we would need to figure out. So our tail is right and our area is 0.75, and our z value is equal to negative 0.6745. So our standard deviation would be equals to our 520 minus 450 over our standard deviation. I feel like I'm doing something wrong here, aren't I? I'm getting a negative answer. That should not be happening. That's pickle. What am I doing wrong here? So 75%. Sorry, apologies guys. It looks like I have made a mistake. Negative. Our x value is 520, and our mean was 450. This is a very low standard deviation. Maybe it's not possible for the standard deviation to change, because it's not possible for something like this to happen at 450. Yeah, apologies guys. I'm not too sure on this one. Like I I'm not too confident on this question in particular. So we're just going to leave it here. So we'll just say for a 50% chance of a plate higher than 520 grams, the mean would have to be 520 grams. So we'll leave it at that for now. And this question, yeah, we'll leave it here. So I will say that the mean will be higher and the standard deviation will be higher, and in order for a 50% chance of a plate higher than for 550 grams, 520 grams, and the mean will have to be 520 grams. So that's all I could think of for this question. So yeah, this is definitely an excellence level question, but what I've done here might not actually be enough for an excellence, because I'm not too sure what the requirement for this question was. But I'm confident to say this is at least a merit grade. Like, this should be at least a merit grade for this much amount of working. For an excellence grade, yeah, like I said, I'm not too sure. I have no idea what the marking schedule is, and this question was not very. I did not enjoy doing this question, unfortunately. So yeah, So sorry about that, guys. Like I said, I'm not too sure on this question. So apologies once again. So thank you for watching this video. I'm going to do question 3 in a separate video. Question 3, I think it's a lot better, so hopefully no confusions there. So thank you for watching this video, and I hope to see you on the next one. Thank you.